Hello everyone, welcome to another video. In today's video, I want to talk about another important interview question in DevOps and site reliability engineering interviews, which is how do you deploy an application from scratch? So once again, here the interviewer just wants to understand whether you have actually worked in a project where you're trying to deploy the application right from the very beginning, right from scratch. Okay, so let's start the discussion. So on my screen, you are seeing a diagram. So this diagram is going to define the entire workflow that I have followed in one of my projects where I was working on an application right from scratch. That means the application hasn't been developed now, and it is only in the discussion. So the top level management in your company has decided to deploy some application, which is to resolve some issue for the customers. Okay, so we'll talk about how our role is defined and how we interact with other people, especially the developers, okay, which we work with very closely. All right, so the first thing that happens is that whatever application you want to design, okay, here I've taken the example of AWS. Okay, so I'm going to deploy the application to AWS cloud. So the first thing is application architecture, that whatever you want to deploy, you should have an architecture for it. Okay, so on this on this diagram itself, you are seeing one application architecture. So this is just a sample example. Okay, it can be any application diagram. It depends on what kind of application you're deploying, what are your exact requirements in terms of cost, how much you want to spend on this particular application, what is your exact requirement in terms of scalability. Okay, so it depends on a lot of factors, but here I'm talking about a very general overview. If someone asks you what you do as a site reliability engineer or a DevOps engineer, okay, so the first thing is, okay, and this is what I have done myself. Okay, so the first thing is my team, that is site reliability engineering. I'm taking the example of site reliability engineering because I'm working in this role currently. Okay, so but in the past I used to be a DevOps engineer. All right, but both the profiles are closely related to each other, so yeah, it does not matter much in general. All right, so as a site reliability engineer, the first thing that I was doing is to design the architecture of this application. Okay, so in some companies you will find a separate AWS application architect who's doing it, but I have done it myself as a site reliability engineer also. Okay, so whatever application you are designing, the first thing is you have to design the architecture for it. So once you have designed the architecture for the application, so what's going to happen? Your designed architecture is going to be sent across for review and approval to senior technical architect board. Okay, so generally this board is called architecture review board. In companies, whatever architecture you design, it's going to be sent across to the senior team for review and approval. Okay, so this team is going to review it and it's going to either approve, or it can provide some feedback in terms of improvements that you can make in your architecture. So just as an example, assume that your architecture was successfully approved by the architecture review board, and now you can start building your application. Okay, now in terms of what application we are developing here, so just assume that you have a three-tier application. Your application has a front end, it has a back end, and it has a database. Okay, that's what the design is about. Okay, and here once again you have to assume that you have a backend you have the backend part of the application that you are working in currently, and this backend part of the application is going to be deployed as pods in EKS clusters, and you have a CI/CD pipeline also set up to deploy your code via this pipeline to the EKS clusters as pods. Okay, now I'm not talking about front end part here because front end will have a separate set of pipelines. Okay, so here we are just talking about one application tier at a time, and that's how it works in real time also. Okay, so here I'm just talking about the backend part of the application, which you need to work with the backend developers to deploy this to EKS clusters. Okay, and this backend is also going to have a database afterwards. The database is going to be an RDS instance hosted in AWS. Okay, so this is how the things are currently. Okay, the first thing once again is going to do is to start developing the code for the application. Okay, so the developer is going to start building the application on his or her laptop. Okay, so here I'm talking about the developer who has all the tools installed on his or her laptop, and he or she has started to work on the application source code. Okay, and once again, the source code, he will have the main source code, he will have the Docker file. After he has developed the Docker file, he's going to do local testing. Now, while developing the Docker file, okay, now once again, it depends. In some companies, you will find developers only writing the Docker file on their own. In some companies, you will find the DevOps engineers or the site reliability engineers helping the developers to write the final version of the Docker file. Okay, so in case the developer is facing any issues with a Docker file, or he's no not able to build it properly, or he's getting some errors, or he needs to have some inputs from the site reliability engineering team or the DevOps team, he or she can reach out to the team and get the input. As a DevOps or site reliability engineering, we should know how to write a Docker file. We should know the basics of Docker file. We should know how to optimize the Docker file. So all that should also be known by our team. Okay, so that's how it works. So you have to interact with the developers multiple times to get the requirement from them and start helping them. Okay, so that's how it works. So now suppose the developer has written the Docker file, he has a source code, he has done some local testing on the application running fine on his laptop. Okay, now the next task is he's going to push this code along with the Docker file and other files for the backend application to the source code management repo, where we already have a CI/CD pipeline setup. Okay, so in this case, a new repo will be created, okay, and the code will be pushed to the new repo. Okay, our job here as a site reliability engineer is he should not have any issues doing this entire thing. So whenever he is pushing the code to the repo, we should be, he or she should be able to successfully do it. And when the pipeline runs, the pipeline should successfully run and deploy the application as pod in the EKS clusters. Okay, since the development has just started, so once again, the pipeline is going to deploy to only the dev cluster. Okay, so once again, in real world, what happens, you will have three different AWS accounts. Here I'm talking about AWS based CI/CD pipeline, which is using GitLab as the source code management. So GitLab is going to be the main repository where you're going to store all your application source code. Okay, so we have three different AWS accounts. We have dev account, we have QA account, and we have prod account. And since we are initially developing the application, so the application will be deployed to the dev EKS cluster via this CI/CD pipeline. Okay, so our job is to just make sure that the developer is able to do it without any issues. If any issues arise, then he or she is going to reach out to us. Okay, this is our first job. So suppose the pipeline ran, and as part of the pipeline, the Docker file was built into a Docker image. The image was pushed to the ECR repository, and then from there it was deployed to the dev EKS cluster. Okay, now this is okay. So now the backend pod is running in the EKS clusters in the dev account. Okay, next, what will happen, or what generally happens, whatever images are being pushed to ECR, okay, as part of the CI/CD pipeline only, there will be a scanning step also. The image will be scanned, and if any vulnerabilities are there, then those will be reported via an email to the developers. Okay, so that's what happens. Suppose that part is also taken care, the image is being scanned, and whatever vulnerabilities were there, they have all been remediated. So now you have a final version of the image that you can actually use in other environments also. So after this local development done, scanning image done, everything on the development side done successfully, the next part is to deploy the same application to the QA environment. other AWS account. So how it happens? Okay, so we have single source code repository here. Okay, on our GitLab server, the GitLab server can be in any of the accounts. It depends on from one company to the other where they want to host this GitLab server. So, for example, this GitLab server is in development account. Okay, which means that this is also running on an EC2 instance, maybe as part of the auto scaling group in the same AWS account where you have your dev EKS cluster. Okay, so now if you have to deploy this same application to other environment, what I mean, how it's going to happen? It's going to happen via the cross account rule. Since this GitLab server is on the dev account, to deploy this application to other AWS account, which is the QA account. So in the QA account, you have another EKS cluster. So again, all this configuration have been done already, where you're going to use a cross account rule to deploy your code to the QA cluster. Okay, I'm just giving you some real-time insights into what actually happens in real world. Okay, so this is how you can do it. This is one of the ways by which you can configure all these things to talk to each other. Okay, so the code is going to be at one place. Okay, but that same code will be deployed to different AWS accounts via the cross account rule. Okay, so this is one thing that can happen. So after the application, the backend application is deployed to QA. Okay, now there's one more thing I want to talk about. After you deploy the application to the EKS cluster as pod, okay, the entire application stack will be tested. For example, you will also have an RDS instance created in the same dev account. Okay, so and you will also have the front end part of the application deployed, and then you're going to test everything. Okay, so you're going to do some test in the dev environment as well, whether our application is working as expected. The backend should be able to talk to the RDS, for example. So that testing will also happen in the dev account. Okay, this is type of a functional testing, you can say, or you can say end-to-end testing done here. Okay, then after this, the application will be deployed to the QA EKS cluster. There, what you will see, you will find some testers, uh, sometimes you will find this designation as SDET. Okay, software development engineer in test. Okay, so these are the people who are going to test your application end to end. Okay, with a different set of use cases or test cases, you can say. Okay, so depending on what type of application you're deploying, there will be some set of test cases that the tester or the SDET person is going to perform on the application. Okay, in terms of testing, I'm talking about, once again, it's going to be the functionality test first thing, then it's going to be performance testing. Okay, so for performance testing, you have you can have multiple test cases that you can test one after the other, and then you're going to create a report on all those different test cases in detail, and those test cases report will be shared by the will be shared with the management, and then they're going to decide whether this testing is good enough to decide whether they can deploy the application to production or not, or they need some more improvement to the application or some more optimization to the application stack. Okay, now suppose the functional testing, the end-to-end testing, and the performance testing is successful. Now the application is ready to be deployed to production. So once again, we are going to use the same source code to be deployed to this third AWS account where we have our EKS clusters. Okay, so after this QA deployment, the deployment will be done in the prod EKS cluster in the other AWS account. Okay, now once again, in Kubernetes we have different deployment strategies. Okay, it depends on what kind of strategy we want to follow. So just as an example, suppose your customers are in two regions. They are in Europe and they are in US. Okay, now in Europe you have only 20% of the users, and in US you have 80% of the users in total. So in total you have like the users are spread 80-20 in ratio, 80% in US and 20% in Europe. Okay, now some companies use something called as canary deployments. Okay, the meaning of canary deployment in Kubernetes is that you are only going to roll out the application version to some audience, or you can say some users only at a time, just to test whether the application is working as expected or not. Okay, so suppose you are doing canary deployment in Kubernetes here. So you are not deploying the application to the US region where you have 80% of the users. You are just deploying the application to the EU region, okay, as part of your canary deployment strategy in EKS clusters. Okay, so once the application is deployed to the EU region, okay, to the uh, live customers, then the performance will be tested, or you can say they're going to take the feedback from all those customers whether the application is working as expected or there are some issues, or I mean, and anything, I mean, it can be good, or it can be bad for your application. Okay, it depends. So after you have the feedback from the customer, and if the customer is happy, everything is working as expected, then you're going to deploy your application to the other region also, which is for the US customer where you have 80% of the users. Okay, so that's how it happens in real world. So after you have I mean, followed this process, you will have a live production grade application running in production to the uh, live users. Okay, so this is the entire workflow that is followed from scratch. Okay, and one more thing I didn't talk about is a security aspect as well. Okay, so whatever application you deploy, whatever things you deploy, of course you have to take care of the security. So I just spoke about the scanning of the images, but we have to take care of other things also. We have to take care of the entire infrastructure that we're deploying for this application. It should be absolutely secure. You should always follow the principle of least privilege in terms of the IAM roles or any other access that you're giving to any pod that is running, or to the users who are using the AWS account to deploy the different resources. So security is one of the aspect. And after this, if I want to add like more to it, after you have deployed your application to these clusters, okay, you're going to create dashboards and alerts also. Okay, so you can use a Grafana dashboard, and you can use a Prometheus as the data source to collect the metrics from these applications, and you can create different type of dashboards depending on what kind of application it is, what kind of monitoring the developers are looking for. Okay, and then of course you're going to get alerts as well. Okay, alerts in there. So yeah, that's how it works in real world. So this is how the entire application works from the beginning to the production, including monitoring, security, and everything that needs to be taken care of. Okay, so in the interview, if the interview is going to ask you this question, that how you deploy the application from scratch, what are the different steps, so you need to summarize all this in 2 to 3 minutes. Okay, I hope the video was useful to you. Okay, so if it was, please hit the like button, please share this video with others, and please do subscribe to my channel. Alright guys, that's all for this one, and I'm going to see you in the next one. Bye for now.